In this lecture, I would like to discuss about the pH metry experiment belongs to the syllabus of MSc semester second physical chemistry. So this is the second experiment I would like to discuss. Already I have been discussed potentiometry experiment that is to determine the formula of the silver ammonia complex. Now let us see the aim of the experiment. Determination of Hammett constant of meta and para amino or nitrobenzoic acid by pH measurements. Determination of Hammett constant of meta and para amino or nitrobenzoic acid by pH measurements. So let us see what is a Hammett constant. Understanding the effect of substituents on the distribution of electron density in the molecule facilitates the understanding of the mechanism of the reaction. Actually, we know particularly in the organic molecules, there is a effect of substituents. Okay, and that substituents also affect onto the mechanism of the reaction. So the proceedings of a considerable number of reaction is facilitated by an increase in the electron density near a definite atom. Generally, the electron donating group or electron withdrawing group affects onto the rate of the reaction or mechanism of the reaction. An increase in the electron density leads to the decrease in the activation energy and consequently a growth in the rate of the reaction, chemical reaction. And increase in the electron density leads to the decrease of activation energy and therefore rate of the reaction will be increases. Now the effect of the substituents at meta and para position of aromatic acids. The effect of substituents at meta and para positions of aromatic acids on the rate of the reaction or equilibrium constant can be studied using Hammett's rule. So it states that, what is the Hammett's rule? It states that the logarithm of, it states that the logarithm of the rate of the reaction, logarithm of the rate constants of the reaction proceeding in the side chain Y of a compound of type A. This is the type A of the compound. It states that the logarithm of the rate constant of the reaction proceeding in the side chain Y of the compound of type A or the logarithm of the equilibrium constant of the reactions affecting the graph Y are linearly related to the ionization constant of the corresponding benzoic acid having the same substituents. That is a compound of the type this second type. Okay, so particularly now in this experiment we are taking the example of benzoic acids and its various substituents like meta and para amino nitrobenzoic acids. Okay, so what is the effect of that meta substituent, what is the effect of that para substituent on the ionization constant of the corresponding benzoic acids that can be studied. Okay, so let us see the Hammett equation here. According to this rule, the equilibrium constant of the substituent compound, the equilibrium constant of the substituent compound is related to the equilibrium constant of the unsubstituent compound. Okay, that is parent position. For example, unsubstituent means benzoic acid. Okay, along with the two constants sigma and this rho. The equation can be written as, this is the Hammett equation. This is the Hammett equation. So in this equation, you can see a log K, that is equilibrium constant, log K0 plus sigma into delta. Or this same equation can also be written in this way by taking the negative sign here on the both sides. So we can write this equation in this way, minus log K, it is equal to minus log K0. Okay, minus log K0 plus sigma into delta or rho. Okay, so this equation can be written as this is nothing but Pk, equilibrium constant. It is equal to Pk0 plus sigma into delta. So we can write this equation now. So sigma into delta, it is equal to Pk0 minus Pk. Okay, Pk0 minus Pk, where sigma and delta are constants. The constant sigma is known as substituent constant. Okay, substituent constant. For example, benzoic acid. If we have taken here the example of the benzoic acid, so in the benzoic acid, carboxylic group is there, and the substituent, suppose that any substituent at meta position or para position, so sigma, it is called as a substituent constant. This substituent constant depends only on the substituent, which type of the substituent is there, electron donating, electron withdrawing. Just like amino group, it is a electron donating substituent, and nitro group, it is a electron withdrawing substituent. Okay, so its value depends upon whether it depends upon the substituent, while the constant delta is known as the reaction constant. This constant delta, it is known as a reaction constant, and its value mainly depends upon the solvent employed, what type of the solvent we have taken during the measurement of the pH. That according to that, this delta value, it is calculated, or it is known. So this is a reaction constant. Now the values of the constant sigma for meta and para substituent. If now here it is a meta substituent, now if it is at the para substituent, can be determined from the ionization constant for the substituted benzoic acid. Ionization constant of the substituted benzoic acid. Suppose that here pK0, it is the ionization constant for the substituted benzoic acid. Okay, pK0, it is the ionization constant of the substituted benzoic acid. Okay, so you can see here, then knowing the values of the constant sigma, we can find the values of the delta. Okay, so the values of the and signs of the constant sigma and delta are characterized the kind of the reaction transformation. So in this way, by using this equation, we can determine the sigma value. Okay, so let us proceed further. Now this table represents some constant values, sigma values. For methoxy group, the sigma value, it is, if it is at para position, it is having the negative value. Methyl group, it is having the negative value here if it is at the para position. Then chlorine group, it is having the positive value of the Hammett constant sigma value. So this is the data which is given here. Okay, so you can see here the values are different here. Now if this methoxy group, it is at the meta position, this its value becomes positive. Okay, and now this methyl group, if it is at the meta position, then it is having the negative value here. Okay, so in this way, by changing the position, the values are also changing. Okay, so try to understand this. Now let us see how to perform this experiment. In this experiment, we are going to determine the Hammett constant, that is sigma value. In this experiment, we are going to determine the Hammett constant, that is sigma value. Okay, of meta and para amino nitrobenzoic acid by pH measurement. The experimental work is very easy here. In this experiment, just we have to measure the pH of the solution. So what are the requirements? To measure the pH, we require pH meter. The combined glass electrode we require. Okay, then burette. Then we require 0.02 molar meta or para nitro benzoic acid. Okay, we require 0.02 molar meta nitrobenzoic acid. Suppose that this is one solution, meta nitro benzoic acid. Then we require 0.02 molar, okay, para nitrobenzoic acid. Para nitrobenzoic acid. Nitro group, it is a substituent. Nitro group, it is a substituent. Or we require 0.02 molar meta amino benzoic acid. Meta amino benzoic acid. Okay, so that is amino group, it is a electron donating group, and nitro group, it is a electron withdrawing group. So in this we require the meta nitro or para nitro benzoic acid solutions. Okay, then we require 50% alcohol to prepare these solutions. Then 0.2 molar sodium hydroxide solution for titration, and we require buffer solution to standardize the pH meter. Now, how to perform this experiment once we prepare the solutions? Okay, now what solutions we are required here? We require this number of the solutions here, you can see. Okay, we require this number of the solutions here. So how to perform this experiment? So suppose that we are having the first solution we want to take here, that is benzoic acid solution. Benzoic acid solution, concentration it is 0.02 molar. Okay, so in benzoic acid we know that there is only one substituent, that is a carboxylic group. Okay, so we can prepare the solution of the benzoic acid, and we have to titrate the benzoic acid. We have to titrate the benzoic acid with NaOH versus NaOH. The concentration of the NaOH, it is 0.2 molar, and the concentration of the benzoic acid, it is 0.02 molar. Okay, so in a beaker we have to take the solution of the benzoic acid, that is 50 ml solution of the benzoic acid. 50 ml solution of benzoic acid. This is our first titration. 50 ml solution of 0.02 molar benzoic acid solution in a beaker we have to take. Then in this beaker we have to insert the combined glass electrode. So suppose this is a combined glass electrode. Combined glass electrode to measure the pH. This combined glass electrode can be used. Then this electrode should be connected to the pH meter. Okay, it should be connected to the pH meter. Okay, so this is the experimental setup. Now before titrating the solution, we have to standardize the pH meter using pH 4 or pH 9.2 buffer solutions. Okay, so standardization of the pH meter, it is the first step. Then take the solution of the benzoic acid in a beaker, dip the combined glass electrode, and then connect that glass electrode to the pH meter. We will get the reading here. Okay, so I would like to show here the readings belongs to this titration of the benzoic acid. So you can see this is the observation table here, benzoic acid versus NaOH. Actually, in benzoic acid, there is no any substituent is present, but we want to determine the pK0 value of the benzoic acid, because it is a parent element, parent compound. Benzoic acid is a parent compound, and substituents are present into the benzoic acids, para amino benzoic acid, para nitrobenzoic acid, and we want to determine the Hammett constant. Okay, so you can see first titration, it is benzoic acid versus NaOH. So volume of 0.2 molar sodium hydroxide solution. So it is placed in the burette. So without addition, we have to measure the pH. That is first reading, it is equal to 3.36. And we have to add the solution of the benzoic acid. We have to add the solution of the NaOH. So then add 0.5 ml, pH will be increases here. Then 1.0, once again pH will be increases. One stage will be reaches there where pH it is suddenly increases. You can see here pH it is suddenly increases at 5.0. Then later on we have to add only 0.1 uh, ml of the NaOH solution, and noted 6 to 7 readings after this equivalence point. Okay, so in this way we measure the pH of the solution. Okay, similarly we have to take meta amino benzoic acid solution in a beaker, and we have to perform the same process. Okay, so we have to perform the titration here. Similarly, we have to take another para-nitrobenzoic acid solution in a beaker, and we have to do the titration. So you can see here. So you can see the procedure belongs to this experiment. Standardize the pH meter that is known to us. Pipette out 50 ml of meta or para-aminobenzoic acid in 100 ml beaker. Okay. Dip the combined glass electrode in the solution and titrate that solution against 0.02 molar NaOH solution from the burette. Initially, we have to add 0.5 centimeter cube volume. Okay, but when the equivalence point will be reaches there, means when there is a sharp increase, sudden increase in the pH, the volume added should be 0.1 ml only towards the end point. Okay. Similarly, pipette out 50 ml of meta or para-nitrobenzoic acid solution and titrate against 0.2 molar NaOH solution. So in this experiment, just we have to perform the titrations. First of all, titration of benzoic acid versus NaOH. Second, titration of meta-nitrobenzoic acid versus NaOH. Then titration of meta-amino benzoic acid versus NaOH. Okay, and we want to see what is the effect of the substituent. Okay, on the pH of the solution. So this pK0 of benzoic acid, it is given value, or we can determine this value also. And this row, it is 1.65 for 50% alcohol. Okay, then we will this value can be used in the calculation. That equation, it is known to us. So let us see now that equation here. Sigma into delta, or sigma into rho. Okay, it is equal to that value becomes equal to pk, pk0 minus pk. Okay, then sigma, that is Hammett constant, it is equal to pk0 minus pk divided by this rho value or delta value. So this rho value, it is given here 1.65 for 50% alcohol. So in this way we can determine the sigma value here. And this pk0, this is for benzoic acid, and this pk value, that is the dissociation constant value for meta nitrobenzoic acid or para aminobenzoic acid. So this value can be determined. So this value can be determined by plotting the graph here. Okay, so after taking the readings, we have to plot this graph. Okay, so plot a graph of pH against volume of NaOH added. So onto the y-axis we have to take pH, and onto the x-axis volume of 0.2 molar NaOH solution added. And you can see here there is a sudden rise in the pH. Okay, sudden rise in the pH. So this is our equivalence point. And at half neutralization, suppose that this point, it is around 7.2. Okay, this is at 7.2 volume. Okay, this is at 7.2 volume. Then take the half of this, suppose that it is Vx, end point of the titration, it is equal to, then take Vx by 2 here. So it is equal to 7.2 divided by 2. Okay, so this is equal to it is equal to around 3.6. Okay, 3.6. So at 3.6 volume, that is half neutralization, we have to take this pH value here. Okay, so that is the pK value we are getting at here. Okay, pK value, it is equal to, pK value is equal to pH at half neutralization, pH at half neutralization. Suppose that this is 3.6 here, so at 3.6 corresponding pH value, it is 4.5. suppose that corresponding pH value, it is 4.5, so 4.5, it is a pK value. Okay, so this graph, it is plotted for all the type of the benzoic acid, meta-nitrobenzoic acid, para-nitrobenzoic acid. Okay, then we can determine the sigma value here. Now you can see this formula, it is given here. Calculate the value of the Hammett constant sigma for the given substituent using the equation sigma, it is equal to pk0 minus pk upon delta. pk0, it is for benzoic acid. Okay, and for benzoic acid we can determine this pk0 value, or this pk0 value, it is given, and using this we will get the sigma, that is Hammett constant here. Now this delta value, it is given here 1.65. Okay, so I would like to show the calculation here. Sigma, it is equal to, suppose that pk0 value, it is 4.2 value, minus pk, it is equal to 4.5 divided by 1.65. Okay, so it is equal to minus 0.3 divided by 1.65. Then the Hammett constant sigma value, it is negative. The Hammett constant sigma value, it is negative. And as I have already shown to you that values, you can see here, if that group, it is para substituted here, this methoxy group, then it is a negative value. If it is meta substituted, then it is having the positive value. Okay, for nitro group, para nitrobenzoic acid, it is having 0.778 value, and meta nitrobenzoic acid, it is having 0.710 value. So in this way, we can determine the Hammett constant values for the substituent group. So in this experiment, we are going to titrate that given acid, that is para-nitrobenzoic acid, para-aminobenzoic acid with pH, with a volume of 0.2 molar NaOH. So simple titration can be performed here. We have to measure the pH, and later on we have to plot the graph. So already I have shown to this graph, and with the help of this graph we can determine the pK value. Okay, so that is at half neutralization. Okay, that is at half neutralization. This is the complete neutralization. Okay, then we can determine the pK value at half neutralization here. Okay, so pK, it is the value at half neutralization. Okay, so we can determine the corresponding pH here at half neutralization, and according to that we will get the Hammett constant here. So the Hammett, the value of the Hammett constant sigma for the given substituent is, so in this result we have to write that. Okay, so this experiment is very simple. Just by performing the titration, we will measure here the pH of the solution. So to perform this experiment, we require the pH meter here. We require the combined glass electrode, and we require the various substituted benzoic acids, para-aminobenzoic acid, para-nitrobenzoic acid, then meta-nitrobenzoic acid, then meta-aminobenzoic acids. And by preparing the solution of that particular benzoic acid, substituted benzoic acid, then later on we have to plot the graph, and with the help of the graph we can determine the pK value. pK0, it is for benzoic acid value. This pK0, it is for benzoic acid value. That value should be given here. Just we have to determine the pK value by plotting the graph here. So that becomes very simple. Okay, so in this way we can determine the Hammett constant. for that particular substituted benzoic acid solution.